Hello everyone. This video is about mid-band analysis of Cascode amplifiers using a small signal model. So to begin with, we have an ordinary Cascode structure. The bottom transistor is Q1 and this one is Q2. And using pi models, we will be able to end up with a small signal model, as is shown in here. The bottom one is like that, the upper one is like that, okay? And more importantly, the low resistance is to be captured by RC here. So what we are going to do is to work out the output voltage first. And for the time being, you probably don't need this schematic diagram. So we will base our analysis solely on this small signal model. And the very first thing that we need is to analyze the sum of current at point A. So we are going to apply Kirchhoff's current law at point A. And from there, we should be able to work out the the voltage transfer function between Vout and Vm. Yeah, remember we are counting on the voltage here. We calculate the voltage here first. For the time being, I'm going to free up some space here, and we are going to work this out. We have the current relation. Applying Kirchhoff's current law at node A. So we have this current going in. This current is going out. Vout divided by RC. And plus this current minus Vm divided by RO2, and then plus this current. And do not forget that V pi, which is the V pi 2 is the voltage across R pi 2 here. And just based on direct inspection, it is actually equals to minus Vm. V pi is equals to minus Vm. So we can rewrite this equation. So equation 1 is Vout over RC plus Vout. I'm going to simplify the I'm going to manipulate the circuit on the fly. And this one is going to be Gm to Vm. So eventually, if you do it carefully, we will end up with Vout over Vm. And according to my analysis, it is RC in yeah, let us do it step by step, right? Instead of jumping step. So we have Vout here, 1 over RC plus 1 over RO2, yeah? And we also have Vm 1 over O2, and then plus 1 over 1 over Gm2. Yeah. Gm2 can be written in this manner, and this is 0. So if you are careful enough, this guy here is equal to R 1 over RC by 2. And Vm here is this guy here, and it is going to be 1 over 1 over Gm2, and then R02. And this one is equal to each other. So it is pretty straightforward. The transfer relations between VL and VM is going to be this guy move up. So I hope this is clear enough to you. So for the time being, we have this relationship. So the next thing is to work out the transfer relations between VM and V in. And for the time being, because we are running out of space, we write down the V analysis here, and then we clean up this part here. So this is our immediate uh, result. C 1 over Gm2 O2. Okay, so we are going to work out Vm over V in. And just think about the resistance that we look up as RC1. The resistance, lump resistance connected to the collector of transistor 1, Q1. So if you remember correctly, Vm over V in is actually uh, is actually equal to RC, and then the formula is quite clean. And now the question is, what is RC1? RC1 is actually this resistance, yeah, if you convert this one into T model, then you will have 1 over Gm2. So in other words, this guy here is actually equals to 1 over Gm1 and 1 over Gm2. So it's pretty straightforward. We are not going to further explain it. So we just do this step by step and say we label this as equation 1, and this one is equation 2. And we just based on the result from equation 1 and 2, we can quickly know the input resistance. So the voltage gain of this cascode amplifier, and it is um, uh, AV equal to V out over V in, and which is also equals to Vm and then Vm times V in. And if you work out carefully, you can we can just substitute this expression into the first one. So C O2 1 over Gm2 O2, and this one here is going to be 1 over Gm1 uh, and 1 over Gm2. Now we have to debate at this point. We have 1 over Gm2 here, and on the other hand, we have an expression 1 over Gm2 in parallel with RO2. And the good thing here is since RO2 is normally greater than this guy, normally, there could be an exception. I don't know. So in other words, we can say 1 over Gm2 in parallel with RO2 is actually equal to 1 over Gm2. So with this in mind, so this guy here so we have to be very brave. This guy here can roughly cancel off with this one. So eventually, what you end up with here is the voltage gain being equal to Gm1 divided by this guy and multiplied by RC2. So you may just assume the bracket, the expression here as the output resistance. And now, what about the input resistance and output resistance? So this is going to be done next. So for the time being, we are going to free up some space in this area. Here, the output resistance here is assumed based on the expression here. We just assume it is equal to RC O2. Yeah, we based on the resistance. Yeah, our analysis in RO1. It is an approximation. Now, the R in, what is R in? R in is going to be the V in divided by IB1. And this guy here is going to be V in IC1 times beta. IC1 is just the column here. It is with you can use it better way. You can use it better way. R in we remember correctly is equal to pi 1 times 1 plus ZL ID. Yeah? We have learned this thing before. Yeah. So now our pi 1 is actually beta 1 divided by what? GM1. So what we are going to get is pi 1 over GM1, which is the resistance here, and then plus RE. So this is what we can get. And the voltage gain here, and the output resistance here. So this is the so-called mid-bound analysis based on small signal model. And if you have any question, please leave your questions to the comment box. I hope this is satisfactory to you. Thank you very much.